Okay, so in this question, we are asked, we're told that a student is investigating some electrical components, and it says describe, so we need to write something here, how the student could set up a circuit to find the resistance of a lamp. So it's asking us to find basically, how do we find the resistance of a lamp, and how can we do that using components that we know and use. So this is worth 4 marks. That means we need 4 good things, good points to get us those marks. And it said you should include a circuit diagram in your answer. So you will lose marks if you don't. It's telling you should do this. So let's go ahead and make a start on that. So when I'm thinking about what I'm asked to do here, I'm asked to find a way to calculate resistance. I don't have a resistance meter. I don't have like an ohmmeter to calculate resistance. That's not something we've worked with, so I can rule that out. So the way that we're going to find resistance is, well, the first thing I know is I can do V equals I times R, and I can rearrange that and turn it into a triangle because I need to calculate resistance. So I'll cover up R and think, right, okay, R equals potential difference divided by the current. That's how I'm going to find resistance. So to physically do that, I need 2 things that are going to measure those things for me. So a voltmeter is going to do that, and an ammeter is going to do that. So these 2 things, voltmeter and ammeter, are going to give me the numbers that I need to divide that by that to get that. So I now know that in my circuit, well, I obviously need a cell, but I now need an ammeter and voltmeter in there. So I can draw a simple circuit down here like so, and it's asking me to calculate the resistance of a lamp. Well, I know the circuit simple is that for a lamp, so just one lamp. So I'm going to put that in there like that. That's really nice and simple. Now I need to add my voltmeter and ammeter. I know that my ammeter always has to be, this is a rule, always has to be in series. So the current is the same all over in a series circuit. So that means I could put the ammeter here or here. And I now need to put in my voltmeter, and I know that a voltmeter, remember I'm measuring the potential difference across the component, so here and here. So I put my voltmeter, which goes in parallel. So now I've got the things that I need to measure: potential difference, or V, and current I. So I can now use this formula. So in terms of the 4 marks, correctly drawing the circuit and correctly placing that would get us 1 mark. The ammeter, correctly placing the voltmeter, would get us 1 mark, so that's 2 marks. And then we're also asked to describe as well for the remaining 2 marks. Well, to do that in my answer, I just need to write down that we would measure current using ammeter, and then measure potential difference, and I wouldn't abbreviate these if I were you. I'd actually write potential difference using the voltmeter. Maybe you would write potential difference across the lamp, and then I would then go on to explain how, once we've measured those, we can use V equals I times R, rearrange to R equals V over I, and then we can use that to calculate the overall resistance. So in terms of my 4 marks, I'd get 1 here and 1 here for my diagram. Then I'd get 1 here which talks about why I'm using these things and what I'm measuring. And then I get my final mark for rearranging the equation to tell us how to calculate resistance. So that's the 4 marks there. The next question is asking us about a particular component in a sealed box. So it says the student is given an electrical component in a sealed box. The student has to find out what it is by experiment. So they don't know what it is inside. They've got to basically interpret the information that they're given to decide what it is. So the student records the current and potential difference for the component, and the results are shown in the figure below. So again, this is an example of you being given information and being able to interpret what you're given to then go on and explain what it means. So the question asks you specifically to explain how the student could know that the electrical component is not an ohmic conductor. Right, so before I try and answer it, let me refresh my memory about what an ohmic conductor is. Well, I know that Ohm's law says that potential difference and current are directly proportional when temperature is constant. Well, I know that's what Ohm's law says, and I know that a directly proportional relationship on a graph looks like that. So I can see that this curve that we've got here is definitely not directly proportional, because it starts off with this really kind of steady gradual increase and then shoots up really quickly. So Ohm's law tells me that potential difference and current are directly proportional to the current is directly proportional to the potential difference applied across the component. But as this graph is curved, it cannot be an ohmic resistor, otherwise an ohmic component, otherwise it would look like this. It would be that straight line, that shows that would be the same as that and the same as that. So to ensure my 2 marks, this would get me my first mark, this would kind of get me my second mark, but just to make sure, I need to write that on in my answer given. So the graph is curved and not a straight and proportional increase. That tells me it's not an ohmic conductor. So the next question, I'll just zoom in here a little bit, asks us to name the component. What is it? So what is the component in the sealed box? And it's worth 3 marks. So I'm going to get 1 mark for saying what it is, and then 2 marks for a clear explanation. Well, I'm going to go back to my graph for some clues here. I can see here there's just no reading of current on this side. So that tells me that if we're to reverse the flow, then there's no current. It doesn't exist. Now, all the components we work with, you can change them around apart from one, and that tells me the one thing that I can't flip around is a diode. So the fact that there's no current displayed, no current on the graph for negative potential differences, if we reverse the current, tells me that it's a diode. So very high resistance for negative potential differences. Remember that a diode only works one way, and that's kind of represented in its symbol with this almost like arrow shape on the play button type shape. So that'll get me 1 mark. So I need to explain that in my answer here. So I'm going to put diode, and I'm going to put no current at negative potential differences, negative PD. So if current was reversed, there would be no flow. No flow. So that get me 1 mark there. I'll do that in green. That'll get me 1 mark there and 1 mark there. And then just to come back to my graph briefly, I also know that it's quite a distinctive curve for a diode. It works at very low potential differences, but it starts off kind of, I'll do it in blue, starts off very, very gradual and then kind of whizzes up really quickly. So I can put that in my answer as well. So diode functions at low potential differences, why they're really efficient, low PD, and the curve starts to increase gradually, but quickly increases at a certain PD. I could be really specific and say what that is. I'll just go back to the graph to do that. And the final question, pretty tricky question, if you don't immediately know how to do it. It says use the graph. So I need to use the graph to determine, to figure out. So the word determine tells me this is like a reasoning kind of question. I'm going to have to use some kind of mathematical reason here to determine the resistance. Excuse me. The resistance of the component at 2.3 volts. So this is worth 4 marks. So I'm looking for a number. It's going to give me the units here. So I don't need to get the units for this to get the marks, but I need to be able to find the resistance of this component at 2.3 volts. It's a little bit clearer. I'm just going to get rid of all these notes here. And there we go. Right, so to figure out resistance from a graph, it's actually really easy if you know what you're doing. It tells me what I need to go in for, so it's 2.3 volts. So here's 2 volts and here's 2.5. I'm going to count the squares. People need to be able to count squares on graphs. This is where you guys are losing a lot of marks. 2.1, 2.2, 2.3, 2.4 and 2.5. So I want 2.3, which is here, 2.3 volts. It's very specific. So I'm just going to take this tangent all the way up and I get to this point here. That's where it meets the line. To find the current at that line, well, I just follow the line where it meets, take it all the way across. So again, I'm going to be really deliberate in the way that I work this out. Obviously in your exam paper you can't zoom in like this, but you can count the dots easily. So I've got 1 here and 2 here, so this in the middle must be 1.5, bang in the middle. And then I've got 1.1, 1.2, 1.3, 1.4. The line, I've not drawn it very accurately, but comes all the way across to 1.2 amps. So now I've got 2 numbers to work with. I've got 2.3 volts and I've got 1.2 amps. And take those back to here. So I've got 2.3 volts, I've got 1.3 amps. I'm going to get marks for drawing these lines on, because that's how I've extrapolated these numbers, that's how I've got that data. I'm then going to get, so marks for using the lines, marks for getting the correct numbers, and then I'm going to get a mark for V equals I times R. I want to find the resistance, so I need R equals V over I. I've got another mark for working that out. So if R equals V over I, resistance equals potential difference divided by current. So that's resistance equals 2.3 volts divided by 1.3 amps. So resistance must equal 1.916 ohms. And here's where it wants the answer. So I'm just going to round it off to 2 significant figures. So 1.92 ohms. And that's my final mark. So I hope you've been marking your answers against the walkthrough video as we've gone along and identified any misconceptions, areas you might have gone wrong. Don't forget to fill out the Google form with areas that you've gone wrong and just generally how you're feeling. Hopefully now you're all feeling great.